Hi everyone, how are you doing? Okay, so I hope everyone is doing good, right? Okay, so let's get started. Can you hear me? Can you quickly confirm? Okay, everyone. Okay, so let's get started. So today we will be discussing questions related to stack and queue, right? Let's see this first question. Now they are saying, uh, just give me a second, just a second. So they are saying, consider how to implement a queue as singly linked list. This SLL list means singly linked list. Okay, singly linked list, and we want to NQ and DQ. Okay, so where we will be NQ and DQ. So suppose if there is a singly linked list, then where you will be NQing and where you will be DQing. NQ means that you need to include or you need to insert some element. So which is better? I mean, okay, just tell me, delete, which is better? At the end, delete is better, or at the beginning, delete is better? I think at the beginning, delete is better, right? So at the beginning, delete is better. Why? Because at the end, it is not easy to make it null, right? I mean, if you are deleting at the end, if you're deleting this element, then how you will be making this null? I mean, we have already seen this because suppose we are maintaining two pointers, one is head and one is, let's suppose, tail. Okay, something like that. Then if you delete this, then you need to make this pointer to null. So which is not possible. That is why delete is, delete at the end. I don't think it is a good idea. You can NQ at the end, right? I mean, if you want to NQ, you can definitely NQ at here. And if you want to DQ, I think it is good. You can DQ from here, right? Okay. So NQ at the tail and DQ at the head. Yeah, I think this is good option, right? Option D is good. So let's just see the answer. So answer is D. I mean, I think earlier there was a typo, but yeah, now it is D. Is this okay to everyone? That what we are doing? So if we are having a queue, right? If we are having a queue, then we will be basically maintaining two pointers. I mean, if we are having a linked list, here we are maintaining two pointers. One is head, one is tail. Now, if you NQ, if you let's suppose NQ here, that is okay. I mean, see, at the head, NQ and DQ both are fine. I mean, at the head, there is no issue. So you can insert at the beginning, you can delete at the beginning. There is no issue at all. But at the tail, there is a limitation. What is the limitation? Can you delete? Delete is not easy here. I mean, easy in the sense, again, you might need to apply the order of n time complexity, which means you need to traverse till this point and then you need to set this pointer to null. So this is not worth doing it, right? So this tail is having some limitation, which is saying that delete is not easy. So you must NQ here and you can DQ here. Okay. Can you do both at the same end? I mean, can you NQ and DQ at the same end only? And let's suppose at the head, if you can do both at the head, then can you NQ and DQ both at the head? I don't think, right? Why? Because in the queue, you cannot delete the element that you have just inserted. I mean, whatever you are inserting, you cannot delete that element. That is the functionality of a stack. So that is why at one end in NQ and DQ are not possible. You have to do it at two different ends. And among those two different end, we have identified that this end, I can do anything, insert or delete, which means NQ, DQ. But at this end, I have limitation. What is that limitation? Limitation is that we cannot delete at this end easily, right? So someone is asking that do we have to guarantee the constant time upper bound in push and pop? No, this is not wrong. It's not like it's a wrong. I mean, it is unnecessarily the higher time complexity. Okay. So it is not wrong. There is nothing. I mean, it is. I cannot say it is wrong as long as the functionality you are providing of NQ and DQ. This is not wrong, but this is not better, right? I mean, these are just intuitive questions. I mean, not exactly I can say not exact question cannot be asked in gate, but some intuition I want to check. I mean, I hope the pre-assumption is okay that with the best time complexity, right? How to implement a queue as a singly linked list with, you can say, best time complexity. Okay, cool. So this is question number 1. Let's see the question number 2. Now they are saying, consider a circular array based implementation of the queue where front and rear has been initialized to -1. Have you seen the videos of queue? That front and rear, like we can have multiple cases. In some case, the front and rear could be initialized to -1. In some case, front and rear could be initialized to 0. Do you remember what was the problem with 0? Suppose that I'm initializing front and rear both to be -1. Okay, this is, let's suppose, case number 1, where I'm initializing front and rear both to be -1. Then in that case, what's going to happen? You will say that whenever you are enqueuing, okay, at that point in time, I mean, you will say that this is rear. And if it is a first enqueue, then I think that probably you will make the front also to be 0, right? If it is a first enqueue. Do you remember this? In case of first enqueue, we will making this also at 0. Like I hope you remember for the -1 case. And in case of -1, what was happening, that I will say that empty condition I can easily write. What was that empty condition? I can say if front and rear both are -1, then this is empty. What was the full condition? Can anyone tell? What was the condition of full? If front and rear both are equal, but not -1, right? But not -1. I think this is the condition of full, if I remember correctly, right? So basically, which means that here, if you want to check whether queue is full or not, then you will be basically inserting R will be keep on incrementing, right? And then the moment you full this R, then it will be come back here, and you will say that front and rear both are equal. Tell me, both should be, for the full both should be 0. Is this necessary? For the full both should be 0 or not? No, right? Yes. Since it is wrap around, like it does not matter. This index does not matter whether both are 0 or not. It should be equal and should not be -1, because -1 was the dedicated case for the empty. So this was easy to identify in case of if we are initializing with -1. Okay. In case of 0, which is a rare implementation, but in case of 0, I think empty and full condition were not easy to identify, right? I mean, in case of 0, I was saying that front equal to rear equal to 0. This condition was for empty also. I mean, here there are two different conditions. But if you are initializing, if your initialization itself is having this, see here the initialization is this, right? But suppose your initialization itself is basically saying front and rear both are 0. Then in case of empty also both are 0. In case of full also both will be 0. That is why that will be, I mean, we have to waste one single cell, right? I mean, there will be single cell wastage. That is one rare implementation that some people do, right? And we have discussed it. But let's not worry about it. I mean, in this particular question, they have asked something else. So they are saying if front is greater than rear, okay, I mean, both are initialized to -1 basically. And then they are saying if front is greater than rear, then they're asking about the size of the queue, right? Okay, front is greater than rear means what? That this is array and front is, let's suppose, here and rear is here, right? So the elements will be this one. These will be the elements, or these will be the elements. I mean, the elements are between front and rear, or rear and front. Anyone remember? Front to rear. Yeah. So basically, I think the elements will be from front to rear. So we can quickly check it. Okay. So suppose that you are initializing front and rear to be -1. Okay. Front and rear to be -1. Now at the first NQ, I think at the first NQ, we will be making this rear to be 0. We will be putting some element. Okay. We will be putting some element. And then we will be making rear to be 0. And what about the front? We will be making rear to be 0. And what about the front? Yeah. So at the first NQ, we will be making I mean, this is one implementation that we did. So basically, this is the first NQ. Now let's do the next NQ, right? So let's quickly do the next NQ. So at the next NQ, you will be saying that your okay, NQ means that you're incrementing the rear pointer. So you will be saying your front is still 0 and your rear will be 1. Your rear will be 1, right? And if you're NQing one more time, then what will happen? Your front will still be 0 and your rear will be 2, right? So let's suppose you NQ one more time. Okay. Then your front rear is pointing here and front is pointing here, right? Okay. So front is pointing here, rear is pointing here. Now these are the subsequent NQs. Now where are the elements? In between front and rear, right? Now tell me the case where I do have something like this, which means I have this as a Q, but instead of this general case where front is pointing here and rear is pointing here, let's suppose the front is pointing here and rear is pointing here, which means I want the elements look something like this. Is it possible? Yeah. So how it is possible? Let's just see. See what could so happen. Let's suppose this is your link list, or sorry, this is your array, and what could so happen? Initially, front is pointing here, and you keep on pushing. So basically, rear will be pointing here, right? Rear will be keep on incrementing, and all the elements are full. Then let's suppose you delete some element. The moment you delete, this particular front will get shifted, right? So let's suppose you shifted till this point. Okay. And you have emptied all of these locations. You have deleted all of these locations. You have shifted this front to be here. Now you start pushing more elements, right? You start pushing more elements. So basically, I will say that this is full. Rear was pointing here. Now start pushing more elements. And then you are saying this is one more element. Now rear is pointing here. Now let's suppose you push one more element and then you will say the rear is now pointing here, right? So basically what you can do, you can ask this front to point here. I mean, because you have DQ'd, and then you can again NQ. So basically this is the configuration which is possible, where index wise I can say that front is basically front, since it is the absolute indexes, right? I mean, since it is array. So this is index number 0, index number 1, 2, 3, 4 like this, right? This is the normal indexing that we have 0, 1, 2, 3. 4, 5, 6. So front value is 4 and rear value is 1. So here this front is greater than rear, right? So how many elements are there? 1, 2, 3, 4, 5. 5 elements are there, right? 5 elements are there. So how to get this 5? How to get this 5? Yeah. Rishesh is saying the total minus empty space. So what is total? That's a very nice formula, I think. Total minus empty space. Total is 7, right? Total is 7. So let's suppose we have initialized the array something like this, right? So, yeah. So I think here in this case, n is 7, right? So total is n, because n is 7, then only we are having 0 to 6, right? Okay. Minus empty space. Empty space is how we are getting this empty space? I think this front minus rear. This will give 3, right? Front minus rear minus 1. Something like this, right? Front minus rear will give 3 and then minus 1 will be 2. Yeah. So this will be the empty space. So finally you have n minus f plus r plus 1, right? N minus f plus r plus 1. This is the condition, or this is one formula that we get if we want to calculate the number of elements in the Q if f is greater than r. So basically, the number of elements in Q if f is greater than r, then what are the elements that we are getting? Just a second. So this is the case, and we are getting this much, right? Yeah. So I think this will work. So total minus empty space is the answer. And here the empty space is seeming to be this. So n minus f plus r plus 1 should be the answer, right? So size n minus f plus r plus 1. Yeah. So I think if front is greater than rear, then this should work. N minus f plus r plus 1 should work. Okay. Is this fine to everyone that S1 is correct? I mean, if we want to get the size means that number of elements in the queue. Then if front is greater than rear, then this is the formula that we are getting. Now, if front is less than equal to rear, which means our normal case in the sense that we have a queue and front is less than equal to rear, right? Which means let's suppose front is here, rear is here. Sorry, front is less than. So front is here, rear is here, right? Let's suppose rear is here. So how many elements are there? 4 elements. And array size is 1, 2, 0, 1, 2, 3, 4, 5. Let me make till 6 as earlier. So basically, our answer should be, it should not depend on, I think, this 6. It should be something like that. R minus f plus 1, right? 4 minus 1, 3 plus 1, 4. So R minus f plus 1 should be the answer. So here, R minus f plus 1. Is this correct? If front is less than rear, then we are getting R minus f plus 1 as our answer. Let me know. Actually, there is a catch. The catch was, I mean, this is correct if front is strictly less than rear, right? We have not checked if front is equal to rear, then what's going to happen? See, if front is equal to rear, then if it is initial condition, okay, where front and rear both are equal to be -1, in that case, if it is initial condition, in that case also it is showing me 1 edge element, right? Which is wrong. Right? Which is wrong. So basically, I can say that if I want to write a function which is get size, okay, of the queue, then I can say if front equal to rear equal to -1, return 0. Right? I mean, size is 0. If front is less than or maybe front is less than rear, or maybe less than equal to, does not matter. I mean, if this case is covered, then I don't care, right? In that case, I was getting R minus f plus 1. Return R minus f plus 1. If front is strictly greater than R, then return. Okay. What was that answer? N minus R plus f plus 1, right? I think. N minus f plus r plus 1. Okay. N minus f plus r plus 1. So return this. So basically, this will be our get size function. Okay. Ultimately, this will be our function. I hope that is okay to everyone. Why did we not do using total minus empty logic? Yeah, you can do that also. So here, total minus empty, like whatever you do, you will come up with the same formula. So total is, I think, n, right? So n value is 7 here. Okay. So this is total minus empty. What is the empty? Empty is this much, right? So how you are going to calculate the empty? Empty is again, I think, n minus this occupied. So whatever you do, you can do it. It's not an issue. No, empty is not r minus f. Empty is, I think, you need to count this, right? So n minus r minus it will be something. See, the empty space is basically this. So whatever is occupied, you need to subtract that. So total minus occupied, right? I mean, that is the empty. That is empty. Okay. So if you do something like this, which is f minus r plus 1, right? So empty is n minus f minus r plus 1. So this is total. This is empty. Empty here itself is different, right? Empty calculation is not easy here. Okay. Earlier empty calculation was easy. Earlier, see, we ultimately want to calculate this occupied location, which is very straightforward in this case. Earlier, this calculation, empty calculation was straightforward, right? Earlier, the empty calculation was straightforward. That's why we have went through the empty, right? I mean, this calculation is straightforward. F minus r plus 1 or whatever, right? This calculation is straightforward. Similarly, this calculation is straightforward. So we can directly do this. Okay. Okay. So basically, finally, I can say that S1 is correct. S2 could have been correct if we say that don't execute this S2 in case of initialization. I mean, the initialization condition is making this S2 incorrect. Okay. Otherwise, S2 is correct. So in general, I can say if that's the question which been asked, so I can say that S2 is incorrect. So basically, S2 is false because when front and rear both are -1, then the number of elements should be 0, but S2 says 1. Okay. See here, if front and rear both are equal, then S2 is saying 1, which is incorrect in case of initialization. Other than the initialization, it is correct. Okay. So that's why A is the correct answer. S1 is true, but S2 is false. It was, I think, little good question. If you were able to solve it, it is okay. I think most of the aspirants might miss this S2, right? That S2 is incorrect in case of initialization. Okay. Has anyone solved it without missing this S2? Okay. So I hope now you understood that this is the final get size function that we should be getting. Okay. Now let's see this question. Consider how to implement a stack using singly linked list if you want to push and if you want to pop. So in case of a stack, if we are having the singly linked list, then what's going to happen? So here push and pop both should be happening at the same end, right? Because whatever we are pushing, we need to pop it. If we want to pop it immediately, we need to pop the same element. If we have to do both, then I think the best idea is to do at the head, right? If we want to do both. So at one end, if you want to do both at the one end, then I think head is the best idea. So we push at the head and pop at the head, right? So I think D is the correct answer here. Okay. Best case means, what is best case here? What do you mean by best case? Okay. So we keep on pushing. We keep on pushing. And then if we want to pop, we want to pop the element that we have just pushed. So both should be happening at the same end. Okay. Yeah. It is basically, you can say, with best time complexity. Okay. Yes. Now let's just see this question number 4. Identify the operation below can be performed in order of one cost. There is more than one correct choice. No marks are given unless you identify all of them. Push an element into stack, insert an element into linked list. What they're saying, there is more than one, no marks are given. Okay, order of one cost. You need to check order of one cost. Yeah, push insert DQ, determine whether the value 10 is in the hash table. Okay, the hashing has not been covered yet, but in case of hash table also, the you can say, like, we will be covering it later, but the order of one cost will be there. Okay, so ABCD is the correct answer here. Now let's just see this question number 5. After applying the following operation on the empty stack, what is the content of the stack? So were you able to do this? You need to push this, you need to pop these two, push 51 and pop, which means 35 and 36 should be the answer, right? 35 and 36. Okay. Yeah, here, yeah, you are right. Here, this insert an element means, like, I mean, you need to insert without caring about the order. Okay, which means, like, I mean, yes, that's true that we should be very specific, that you can consider this as an insert at beginning. Yes, you are right about it. So we need to, I mean, consider insert at the beginning. Okay. After applying the following operation to the queue, I think you can do this also. So you enter, I mean, you NQ, 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 DQ, DQ, you DQ, DQ, NQ 51, and then DQ. So I think 8 and 51 should be the answer, right? A is the correct answer here. Okay. Now let's see this question. We have 3 stacks, S1, S2, and S3 with their initial content. As you can see, initially S2 and S3 are empty. Here is the sequence of operation on these 3 stacks. So you can perform these operation and then you can draw. I think this question is doable, right? So the 6th question, this is the final answer, part A. Part B is saying, this question is about the same 3 stack. We add the rule that when you pop an element from the stack, it can only be pushed to the higher level stack. For example, if we are doing okay, this kind of operation is not allowed. Suppose we start from the initial state, part A, and eventually move all the strings to S3. Okay, so basically we want to move this to S3. It is like top of an I or something, and then here you cannot basically directly push here. I mean, they're saying that you can only push to S2, and then you can push to S3, right? So how you can do it? How you can do it? So I think you can just transfer that to S2. That's very easy. So if you transfer, it will be reverse, right? 2, 1, 0. And then you can again transfer to the S3. So yeah, I mean, okay. So basically you can transfer that to S2, pop and push to S2, and then pop from S2 and push to S3. Okay. Then it will be 0, 0 first, and then 1, and then 2. Something like that. Okay. They are having 0, 2, 1. Just a second. 0, 1, 2, 2, 1, 0. So what they're saying, this question is same about S1, S2, S3. We add a rule that you pop an element from the stack. It can only be pushed to the higher level stack. Okay. For example, this S3, you can't pop from S3 and push to S1. Okay. So, okay, it's like that you can pop from S1, and then you can, if you're popping from S1, then you can push to S3. That's okay. Yes, I think we can directly push. Suppose we start from the same initial state in part A and eventually move all the strings to S3. Give an example of ordering to the elements 0, 1, 2 that we cannot attain on S3. Okay, cannot attain on S3. So they are saying that what kind of ordering that we cannot get on S3. So basically the question is like that we are having this initial configuration. Okay, let me maybe move to the next slide. Let me take this to the next slide. And then they are saying that if we are popping, the condition that they are putting is that, okay, the condition that they are putting is that if we are popping, then we cannot push to the previous stack. I mean, then we can push to the next stack. I mean, the higher level stack only. Okay. Then we can push to higher level stack. Okay. So basically, if we're popping from this, if you pop this 2, because that's the only operation as the first operation, at least you need to pop from S1. So let's suppose you pop from this, you write it either here or here, doesn't matter, right? I mean, let's suppose you write it here. Okay. Yeah. So that is fine. Now, this 1 is there. You can put 1 here or you can put 0 here. Doesn't matter, right? I mean, if 2 is there, if 2 is in S3, if 2 is in S3, okay, then after 2, you can have 1 or you can have 0. So basically, both the combinations are possible, right? After 2, both the combinations are possible, right? I mean, I do not need to care about whether it is 0, 1 or 1, 0. So both the combinations are possible. Let's just see. Let's just see. Instead of 2, let's suppose, instead of transferring this 2 here, let's suppose I transfer this 2 here first. Okay. So suppose, is this clear to everyone? The first thing that I'm saying is this, that if 2 is here, if 2 is here, if you directly transfer this 2 here, then you can put this 1 or you can put this 0. I mean, both the orderings are possible, right? So this is one thing. Now, let's just check the other thing. Okay. So suppose I want to check whether instead of putting this 2 here directly, let me put this 2 here. Okay. Now, this 1 is there, right? Now I can put, so there are two cases. I can put directly 1 here. So there are two cases from here. So basically, this is S3, this is S2, this is S1, right? So what I'm saying, I think we need to check many cases. So let's just check it. So what I'm saying is this, that you have put this 2 here, right? You have put this 2 here. Now, what about this 1 and 0? Let's suppose you put, in one case, you put 1 here. In another case, you put 1 here and 0 is still there, right? Okay. Now, 1 is here. Then also this 0, 2, any combination is possible, right? I mean, if 1 is here, then 0, 2, you can write anything. See, earlier 2 was here, then 0, 1, anything was possible. If 1 is here, then you can write 0 or 2. So both combinations are possible with 1 also. So basically, you can say in S3, if 2 is here, then these two combinations, either 0, 1 or 1, 0, both are possible. If 1 is here, then also 0, 2 or 2, 0, both are possible, right? In S3. So let's just check the last case. If you have 0, okay, if you have in S3, if you have 0 here, if you put somehow 0 here, then do you have both the cases? Okay, this is the only thing that we need to check. Is this okay to everyone? So basically, we have checked, if you're putting 2 here, then both of these cases are possible. If you're putting somehow, if you're putting 1 here, then also both of these cases are possible. Now let's just check if you're putting 0, then also is both of the cases are possible or not. So 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 suppose, let me copy that. How to put 0 here? That is my first question. 0 is the first element. See, once you push in this S3, there is no way to pop. I mean, you cannot pop here and you cannot push back to anyone, right? So, I mean, you cannot directly push this 2. If you want 0 to be here, if you want 0 as the first element to be here, can you push any other element before 0? See, if you push, let's suppose 2, then you cannot pop it out and you cannot push it back, right? I mean, the only push that is possible in the front or the subsequent stack. So if you want to have 0 here, then the only possible case is that 0 should be the first element, right? Which means you need to write this 2 here. You need to put this 1 here, right? That is the only case. Now you need to put this 0 here, right? This is the only one and only way that 0 could be at the S3. Now there is only one way, since you can transfer from here to here. Now there is only one way that you can have this 0, 1 and 2. So basically it will be 0. And then after that, this is force that you need to put 1 here and then 2 here, right? You cannot have 2 and 1. You cannot alter this. So that's why this is possible, but this configuration 0 and then 2 and 1, this is not possible. Okay. I mean, you just need to have some aptitude to solve it. So basically these stack and queue questions, you might have noticed one thing, that like most of the question does not require your specific knowledge of stack and queue. Okay. I mean, some questions like the programming implementation questions like this, okay, like this, they might require some knowledge of stack and queue, like internal details of stack and queue, how you're implementing and all. But most of the questions I'm telling you, they are just aptitude kind of questions in stack and queue. And I don't know, but I have observed it that these questions are generally very hard. I mean, you try to do anything in stack and queue, they automatically become very hard. Okay, so most of the questions you might observe in stack and queue, these are, I mean, apart from this normal questions, we are having most of the questions which are basically related to aptitude only. So we will be seeing questions, okay, and mostly you will observe that to solve those questions, the knowledge from stack and queue that is required is just the basic definition of stack and queue. See, just to solve this question, do you need to know the implementation detail of stack and queue, whether you are implementing using queue, using array, using linked list, or how you are implementing? Do you need to know that kind of information to solve this question, that how stack is being implemented? No, right? See, this stack and queue are called abstract data structure. So what is abstract data structure? Can anyone tell me? What is abstract? What does this abstract mean? Do you remember? Anyone? Yes, we are hiding the details. The implementation details are being hidden. That's what abstract mean, right? So I talked about it, if you remember, in one of the very first lecture, I think, right? So the first lecture itself talked about what is this abstract in case of abstract data structure. So basically, what I'm saying here is that these stack and queue questions are literally kind of aptitude question, because you do not need to know the implementation detail in most of the questions. And unfortunately, or maybe like I have observed it, that even though these are the aptitude question, but still these are too hard. Okay, I mean, most of the questions are very tricky in case of stack and queue. Even when we will be solving the PYQs, you will be shocked to see that these questions are literally very hard. Okay, I mean, some of the PYQs of stack and queue, I think 3 or 4 PYQs, or at least 3 PYQs are there regarding stack and queue. They are, I mean, very tricky. Have you observed those PYQs? I think there was one PYQ. I do not remember exact year or exact words, but from the last year I remember there was some x plus 2y, some options, something like that was there. Anyway, and there was one more PYQ. So basically 2-3 PYQs are quite very tricky. And in those PYQs, it's not like that that you have not understood the topic, that's why you are not able to solve it. Let's suppose that I teach you stack and queue very well, okay? And what can I teach in the stack and queue? The implementation detail only, how stack is being implemented, how queue is being implemented. And now suppose if someone asks you, okay, we will be solving those questions only, but if someone asks you some tricky aptitude kind of stack and queue question, is it the fault of lectures or is it the fault of you? There is no one's fault, right? I mean, the question itself is very different from what we have studied. You're getting my point? Because this point is very important for you to understand. Because you should not think that, okay, you are not able to solve a stack and queue question, that's why you are not you have not understood this topic. No, it's not the case. Okay, just understand that very clearly, that if you are not able to solve any question of stack and queue, it's not the case that you have not understood it. It's just the case that these kind of questions are very different from general subject questions. I mean, general data structures, algorithm, C programming, or any other subject question. In any other subject, what does happen? Whatever we study, at least the question is from that concept, right? I mean, whatever we are studying, the question is at least from that concept. But here, in case of stack and queue, whatever we are studying, that is just implementation detail, but the question could be very different from that, because these are the abstract data structure. You got my point? Okay. So I hope I'm clear about it. So hello. Yeah. So I think you can hear me, right? So yeah, okay. So what I'm saying is that if you're not able to solve a stack and queue question, it is fine, because I cannot do anything here. And to be honest, sometimes and not sometimes, many times I also wonder like how to solve these questions, because these questions are not the questions that we have seen in the lecture. These questions are different from what we are seeing in the lecture. Because in the lecture also I cannot teach. Or like how can I teach? Because every question could be different. When you solve PYQ, you will notice that things are very, very different. Okay. Okay. So let's just continue. Okay. Let's see this question. Consider a sequence of push and pop operation used to push integers from 0 to 9 on a stack. The numbers will be pushed in order. However, the pop operation can be interleaved. So I think that's what you know, right? That is called stack permutations. So have you solved this question? What is the answer you're getting? What is the answer you are getting? Can you get this 0 to 9? I think we can push pop, push pop, right? So everyone is getting C as an answer. Okay. So A is possible. Okay, this is possible. How it is possible? You can push and pop. You can push 0, pop 0, push 0, push 1, pop 1, push 2, pop 2. Like that, this is possible. Is this possible? See, this is 0, 1, 2, 3, 4. This is reverse. This is single. So you can push 0 to 4 and then you can pop it, right? So you push 0, 1, 2, 3, 4, and then you pop all elements, pop all elements. Then you will be getting this sequence. Then you push 5, pop 5, push 6, pop 6, right? Then push, pop. Okay. Have you understood what I'm saying? So that's why this is also possible. What about C? C is saying 5, 6, 7, 8, 9, 0, 1, 2, 3, 4. Let's just check if C is possible or not. So 5, 6, 7. This is the same order. So basically till 0 to 4, you push 0 to 4, right? Which means 0, 1, 2, 3, 4. And then you pop, push 5, pop 5, push 6, pop, say, I mean, 5, 6, 7, 8, 9. You can do this much, right? I mean, you can push and pop immediately. Then you need 0. I don't think it is possible, right? You cannot get 0. So that's why C is not possible. So yeah, this is not possible. What about D? 1, 2, 3, 4. This is 0, 1, 2, 3, 4. This is reverse. You do, I mean, you push and then push from 0 to 4 and then pop all the elements. I think you will be getting this. Then 5, 6, 7, 8, 9. This is also reverse. So which means you push till 9 and then pop. Yeah, this is also possible, right? Okay. So I hope you understood that C is not possible. Cool. Yeah, now let's do this question. This is very nice question. A little tricky, I think, very tricky question. This is one of the question that you might see in your masters. I mean, when you do MTech, I mean, this is one of the method that people use in the advanced data structure or something. Okay, so let's just see this question. Were you able to solve this question, by the way? Anyone? Case case B is interesting, right? Anyone has solved case B? Okay, nice, nice. So let's just see this question. The array-based stack has the limitation, which is we cannot push more elements than the capacity of the array, right? Okay, that is what you know. Whatever is the earlier capacity, which means if you are initializing int a 50, then the size of stack will be 50 only, right? You cannot push more than 50 elements. That is for sure, because this is static. I mean, you cannot increase the array size dynamically. This approach involves, so consider the following alternative. This approach involves dynamic allocating a larger array using a malloc function whenever the size of the stack is full. So if the size of the stack is full, let's suppose this size is full, then we can push more elements than the current capacity of the array. And here is how it works. So suppose the array is full, then to push the next element, we first allocate a new array of the larger size. So this is very important to understand. Now what they are saying, that if the array is full, okay, see, they are saying that if the array is full, then what you do, suppose that you are pushing, but the array is full. So this is occupied, this is occupied, this is occupied. Now, can you push more elements? In general, you cannot push, but they are having some different implementation. They are saying if the array is full, then what you do? Suppose the array is full, then push the next element. Then to push the next element, we first allocate a new array of larger size using malloc. So basically what we will be doing, we will be doing the malloc, that is dynamic call. I mean, dynamic, you can say dynamic memory allocation, right? Which is done using malloc, and copy all the elements. So we will be copying all of these elements and to the new array and free up the old array. And then we will be freeing up the old array, right? And then we will be saying that, okay, now these are the 1, 2, 3, 4, 5, 6. Okay, this is 1, 2, 3, 4, 5, 6. And now the seventh, the new element can go here, right? Because this is the larger element, larger array. Element can go here. So have you understood how they're implementing this dynamic size array? So they are saying that if you want to push more elements than then what is already being pushed, then what you do, you basically allocate a new array of larger size, right? What is the size of this? 1, 2, 3, 4, 5, 6. Size of this is 6. What is the size of this? 7, right? 7. Now they are saying that it is not, obviously it is not necessary that the new array, this is the new array, isn't it? The new array can be just one larger than the previous size, or can be maybe double of the previous size, or maybe just 5 larger than the previous size, or something like that, right? So basically what I'm saying, this is the old array, this is the old array, this is the new array, right? Okay. Now the new array size could be just one greater than the old array size, could be double, could be can the new array size can be like let's suppose the old array size is 6, can the new array size will be plus, can be plus 1? Yes, it is possible. Can the new array size could be plus 6? I mean, could be double? Yes, it is possible. Can some arbitrary number plus some arbitrary number possible? Yes, this is possible. So the new array size could be anything, right? And that's where the two cases are. The case A is saying that when we create a larger array with a size 1 greater than the old array, case A is saying that you create a new array, but the new array size is just 1 greater than the previous array. Case B is saying when we create a larger array with a size double of the old array, okay, which means whatever is the earlier size, I will be asking for the empty space which is double than the previous array. So there are multiple cases. In both cases, the objective is to determine the total cost incurred when pushing n elements onto the stack. That's interesting, right? Have you understood the question at least? That's a very interesting question. Have you got to understand the question? Okay, everyone? Okay, that's great. Actually, like just a variation of this. So basically here I'm having two cases, right? One is that +1 and another one is a I mean plus n, I mean 2n, right? 2n, this is n+1. I mean, whatever the earlier size +1, whatever the earlier size multiplied by 2. This is in general plus k. Okay, I mean, you can have some arbitrary plus k also. Now I'm solving these two cases. Can you solve this case by yourself? Once I solve these two cases, tell me. Let's do one thing. You actually, you don't have choice. You have to solve it because that is the question of quiz. Okay, that is already a question in the quiz. So like I will be explaining these two here, but in the quiz that is already a question. I need not to, I mean, think about it and make it. That is already one question that that I have put in the quiz, that you need to increment by the k. Okay. No, quiz to dena hi hai. So Twinkle is saying that quiz dena nahi dena. See, in the quiz, it doesn't matter how much marks you are getting or what you are doing. If you, I think if you hear from most of the toppers, then they will say that quiz is very important. I mean, most of the previous year toppers. So don't skip quizzes. Okay. So doesn't matter how much marks you are getting. It is okay if you are getting the less marks because quizzes questions are actually challenging ones. Okay. So let's just solve this question. Now, suppose there's a case one. Okay. Case one is saying, whatever is the earlier size, case one is saying, we create a larger array with the size one greater than the old array. Okay. Now, in both the cases, assuming in the both the cases, the stack size or the array size is initially one. Okay. So let's solve these two cases. Initially, it is one. The question is that initially the size of array or the size of stack is one. We want to push n elements. Okay, we want to push n elements and we need to check the cost of n elements. So let me just explain. Okay, sorry. There was some disturbance, was it? Just a second. Okay. Since how much time the disturbance was there? I won't actually my speaker was on the mute. Okay. Okay. So I hope that is fine. Okay. You guys could have told me. Okay. No, not an issue. So let's just continue. So basically what I'm saying, I hope you heard me, right? So what I was saying that let's just solve this case one. Initially the array size is one. Okay. This is the initial array size. Now you push one element. If you're pushing one element, then this is full. Now to push the next element, what you will be doing? So to push one element, what you did, how much cost you required? The first element. Just to push the first element, I think the one cost is required. Okay. Just to push the first element. Okay. Let's not talk asymptotically here. Let's just, I mean, I want to sum all the questions. Let's just solve in, I mean, the numbers. So the cost was one, right? Okay. Now, if you want to push the next element, okay, if you want to push the next element, then how much cost it will require? What you need to do, you need to first double the size. Oh, sorry, you need to first, I'm in the case A, okay. You need to first increment the size by one, right? So basically, this is your new array. This is the old element. This is the first step. I mean, you have to do all of this. And then you need to push. So how much time you think it required? Let's suppose that malloc is taking the constant time. Okay, malloc doesn't take any time. Assuming the cost of malloc is a constant. Okay, let's forget about the malloc. So basically, you can create a space. You need to copy this element. You need to push one more element. I think two, right? Because you need to basically fill both of the spaces. So for the next element, you require two cost of two, isn't it? For the next element, you require cost of two. Now that is done, right? Now you need to push one more element. Okay. So to push one more element, what you will be doing? Now the array is like this. If you want to push one more element, then you will be saying, that I need to create one more. I need to create, the new array. The creating the new array is taking the constant time because the malloc is taking the constant time as per the question. So let's suppose it is taking the constant time. Then you need to, obviously, you need to copy these two. And then you need to push this, right? You need to push this. So basically, you need to push these two and then you need to push this. So I think it will be required. It will require 3, right? It will require 3. Because 2 for this and 1 for this. It is just like as good as empty array, and then you are copying all the elements. So for the 4 elements, it will require 4, I think, right? For the 5 elements, it will require 5. For the n elements, the total cost will be something like this, which is order of n square or theta of n square. Is this okay to everyone? Okay. I have one question here. Can anyone answer this question? Just check that you have understood this asymptotic time complexity well or not. Okay. So just tell me here, can I ignore all of these terms and can I just say the significant term is n? So theta of n should be the answer. And if no, then why? Why no? Okay. All of you are saying no. Can you tell me why no? Because the number of terms that we can ignore should be the constant terms, right? We cannot ignore the function terms. The number of terms cannot be the in terms of n. Yeah, the number of terms itself is n. That's why we cannot ignore. Yes, number of terms are in n. Yes, that's true. So that's why we cannot ignore, right? Okay, I hope you understood. So basically, the first case answer is order of n square or theta of n square, right? Theta is also possible here. Cool. Now let's just talk about the second case. Second case is actually extremely interesting. So let's just talk about it. Okay. So initially, again, here also the array sizes, let me just delete it. So initially, the array sizes here also the 1, but the we push one element, then the cost will be 1. The next element we are pushing, before that we will be doubling the array size, right? We will be doubling the array size. Then you need to copy it. You need to copy this and the next element. So the second element will be taking how much time? 2, right? 2. You need to do it. Yeah. Now you need to push one more element, but before that, what you will be doing, you will be doubling the size. So 1, 2, 3, and then 4. Okay. You need to double the size. So here, these 2 element copy and the third element copy. So for the third element also, we got 3. What about the fourth element? Just 1, right? Order of 1. So for the fourth element, it is very interesting. The fourth element, we don't need to do anything. Now for the fifth element, what do we need to do? We will be creating an array of size 8. 1, 2, 3, 4, 5, 6, 7, 8, whatever, right? So basically, for the fifth element, again, we will be taking 5 because for this copy and fifth one copy. So for the fifth element, again, we will be taking this. But for the 6th, 7th, and 8th, these elements, we will be taking just order of 1. Isn't it? Now for the 9th element, we may take 9. We may take 9. But for the 10th, at this point in time, the array size is 18, right? Sorry, 8 into 2, 16, something like that, right? 16. Now for the 10th element, 11th element, 12th element, 13th element, 14th element, 15th element, 16th element, we don't have to do much things. We can just do in order of 1. So basically, we need to put suddenly very high cost, but for most of the time we are spending order of 1. Is this clear to everyone? We will be seeing that what kind of series it is making, but at least this kind of intuition is clear to everyone that we are going linear, and then suddenly some high cost. Cool. Linear. Just 1, and then suddenly maybe some high cost, right? 16, something like that, right? Okay. So I hope that is clear to everyone. Now, when you are taking some high cost, whenever the insertion is basically, you can say it is 8th element or 9th element. If it is 9th element, like let's not worry about the -1 + 1. So basically, if the insertion is 2 power ith element, right? If 2 power ith element, I mean, if it is fourth element, I mean, एक्चुअली इट शुड बी फिफ्थ एलिमेंट, फोर्थ एलिमेंट तो ऑर्डर वन ही होगा. फिफ्थ एलिमेंट के केस में मतलब वो हो जाएगा ना, फिफ्थ एलिमेंट के केस में वी नीड टू डबल दिस साइज एंड दिस थिंग, बट दैट इज फाइन. आई मीन यू कैन से 2 power I plus 1, doesn't matter. Okay, so basically if the element index or the element number is 2 power I plus 1 minus 1, does not matter, like you can do plus 1. Okay, I mean if the element number is 2 power I, okay, then I mean if it is in 2 power, the element number itself is element, I mean कौन सा element push कर रहे हैं. Let's suppose if I'm pushing, maybe let's suppose 7th element. So 7th element, if someone generally ask you, in general someone ask you, so 7th element के लिए कितना cost होगा, what you will say? Just 1, right? What about the 8th element? 8th element के लिए कितना cost होगा? Size, just imagine the size in your mind. Size will be either 4, right, or 8, or 16, or 32, something like that. So अगर if that is basically, let's suppose if that is here, I mean 7th element है या 8th element है या 9th element, 9th के केस में चलो ठीक है ना, 10th element है, 12th element है. So in those cases, like in 8th element also order of 1, something like that, right? So basically, I mean, you can say plus 1 or minus 1, does not matter. But basically, you will say that if it is, let's suppose 8th element, I'm considering 8th element. Let's suppose the index will start from 0. Okay, doesn't matter. This plus 1 minus 1 doesn't matter. I don't want to confuse you. Basically, what I'm saying, that if the element index itself is in 2 power, someone asks you 12th element, you will say order of 1. Someone asks you 16th element. Okay, if the index itself is in 2 power, in this index itself is in 2 power, then you will say then the cost is 16. क्योंकि you have to create identical copy. I mean, you identical copy, or you have to create, I think, more, yeah, identical copy, right? You have to, I mean, you have to create the double size, which will take order of 1, and you have to copy all the 16 elements. So 16th element के लिए order cost will be 16. So basically, if someone asks you that first element के लिए, you will say it is 1. Okay, I mean, okay, let's not worry about the first and like this. Initial 4, 5 को ignore करते हैं एक बार. Fifth element के लिए, let's suppose you say order 1. Okay, I mean, let's start from this. And 6th element के लिए you will say order 1. 7th के लिए order 1. If it is 2 power, if it is 8th element, you will say suddenly this is 2 power cost. Cost is also 2 power I, right? 9th element के लिए order 1. 10th element order 1. 11th element order 1. 12th element order 1. 13th element order 1. 14th element order 1. 15th element order 1. 16th element, which means 16th element, then order of 16. I mean, sorry, not order of 16, 16 cost, right? Okay. Yeah, for 8th, it doesn't, for 8, it should be 8, or for 9th, it should be 8, doesn't matter. I mean, plus 1, minus 1, you can do, but you can understand like this, that it will not always be in 2 power. In rare cases, it will be 2 power, right? If the index itself is 2 power, then only 2 power. Otherwise, in most of the cases, just order of 1. So how you can sum this series? Okay. So basically, I got a function, okay, which is 1 if I mean, something like this, right? I mean, if that index itself is in 2 power, then I have that cost. So let's suppose this is the cost. I need to sum up this series. So this is kind of the series I'm getting. If that is in 2 power, I will be adding 2 power. If that is not in 2 power, I will not be adding 2 power. Okay. So can you add the series? So basically for 1, 2, 4, 8, 16, right? For these cost, this will be that much cost, and otherwise it will be that much cost. Okay. Let's suppose the total number of elements that you want to push is n, right? n is the total number of elements. So maybe I can move to the next page. Total elements we want to push is n. So let's do one thing. This is, let's suppose, first insertion. This is second one. This is the third one. This is the fourth one. This is the fifth one. This is sixth one. This is seventh one. This is eighth one. This is ninth one. And similarly, there will be nth one, right? So this first or second doesn't matter. So basically, these kind of cases. In these kind of cases, I will be spending this much time, right? Is this okay to everyone? Otherwise, I will be spending one everywhere, one, right? Is this okay to everyone? Okay. It won't be 2 power n because the total elements itself is n. So it will be 2 power log n or something. Okay. I mean 2 power k. So anyway, so basically, let's suppose that it is going, the series is going till n, or in terms of 2 power, if I want to write asymptotically, let's suppose it is going till 2 power k. Okay. So which means that I'm writing asymptotically, which means that n might not be exact of 2 power, but we assume that it is of 2 power. Okay. I mean n could be 10 also, n could be 100 also, but that's fine. I mean, the nearest 2 power you can take, whatever the nearest 2 power, it won't matter much. Okay. So n is, let's suppose that n is in 2 power. Okay. In these kind of cases, in asymptotic comparison, you can always take n to be 2 power k. Okay. If that is required, that is perfectly fine, because anyway, n is very large, right? So whatever the very, very large number, you can take it as 2 power. The reason being is that if it is not 2 power, then you can assume that, let's suppose n is 10,000. Okay. Or something. Then that is, or maybe let me just give you with a small example. N is, let's suppose, 100. Then to what 2 power you will approximate this n? 2 power 6 is 64. 2 power 7 is 128. To what 2 power you will be approximating? 6 or 7? 7, yes. So just approximate with 7, because I mean, you just assume that I mean, you are doing the calculation even for something larger, right? Just approximate it for something larger. So basically what I'm saying, even if n is not in 2 power, you should not be worrying about these small things. Okay. So let's suppose n is 2 power, which means it is going from 1 to 2 power k, where n is equal to 2 power k, which means k is log n. So what can I do here is that I need to sum this 2 power 0, 2 power 1, 2 power 2. So basically these are the cost that I will be taking for just 2 power, isn't it? Just for these indexes, I will be taking these costs just for these indexes. This also, right? You can include this. So basically just for these 2 power, I will be taking this cost. What about the remaining? Remaining also I have to add, isn't it? Is this okay to everyone? That just for these 2 power, I will be taking this cost, but the remaining I also have to add. Let's suppose the remaining, I mean, even the remaining will be less than n, but let's suppose it is n. I mean, it will be n minus, I think these are the k numbers, right? N minus log n or something. Because these are the k numbers. I mean, हर किसी को अगर 1 भी मान ले, तो सबका summation will be n. But since these summation won't be included, and these are the k terms, right? These are the k terms. So n minus k will be something like that. But let's assume this is n. I mean, which means that I'm doing some approximation. सबको एक ले लिया, सबको 1 ले लिया. Okay, then I'm getting n. And इनका extra भी ले रहा हूँ. Okay, then I'm taking the extra of this. So I hope that is fine. So basically, I can take it as n. Right? So I can say that this is just for 2 power. This is for the remaining ones. Is this fine to everyone? See, if I take every cost as 1, then it will be n. Okay, so I'm taking every cost as 1, which means I'm covering this, and then little bit extra I'm covering, because here I'm counting this one extra, this one extra. If you don't want to count, then these are the, I think, k terms. You can just do minus k. Okay, I mean, n minus k terms are these are the n minus k terms, which are not in 2 power. Okay, because 2 power terms are k, right? 0, 1, 2, 3, k or k plus 1 doesn't matter. Okay, so basically this is n minus k, like this. It is gp, right? Asymptotically, can you tell me what is the answer here? 2 power k, right? It is an increasing GP. 2 power k is n. So basically it is 2n minus k. K is log n, so 2n minus log n, right? And that is why order of n or theta of n is the answer. Okay. If you sum all of this cost, then theta of n is the answer. Okay. So basically, interesting thing that we have observed in the case 2 is that case 2 is so nice that even you have, like, what is the benefit of case 2? That you are inserting n elements, then ultimately the cost is n. See, earlier also in the usual stack, what used to happen? If you're inserting n elements, can you tell me the cost for insertion of n elements altogether? If you think a larger picture, if you push n elements, then I think the insertion cost will be order of n. In earlier case also, right? I mean, and because everyone is order of 1. But here, everyone is not order of 1, that I agree. Sometimes order of 1, sometimes order of 1, sometimes little higher, sometimes little higher, sometimes order of 1, right? Sometimes order of 1, sometimes little higher. But ultimately, if you sum all of this, then it is also order of n. See, earlier everyone was 1, right? Everyone was 1. Now, everyone is not 1, everyone is not 1. Sometimes it is 1, sometimes it is 2 power. Okay. I mean, sometimes I'm incurring too much of cost, but ultimately, as a bigger picture, if I see, then ultimately I'm getting theta of n. So here I'm getting two benefit. What is that benefit? Overall, n pushes are also getting order of n cost only, but this is the dynamic stack, which means I do not have to worry about the size. Okay, that is why, I mean, this is one advantage of this. That is why this kind of strategy, which is the doubling the old array size, this kind of strategy are being used somewhere. Okay, in the advanced data structure, you will see this. Okay, cool. Is this understood to everyone? Yeah, that is one question, that why I have taken n equal to 2 power k. That I will address. But apart from that, everyone has understood this. Okay, so basically, this is actually to be let me share you one story. What happened in actually, I think this is the advantage of doing the masters, that somehow it get appears in our lectures also, either in the question or in the lecture, somewhere it will come. So let me tell you the story of this question. So how this kind of question came into my mind. I mean, why I thought that this is a relevant question, because one day I was studying in ISC algorithm lectures. So that strategy was just discussed as a normal strategy. I mean, there is one professor, his name is Anand Lewis, and he is PhD or masters from Princeton University. You might have heard about the Princeton University, right? So yeah. Anand Lewis is he's Indian only. He was one of the youngest professor as ISC, I think. At just the age of 30, he was the assistant professor there, which is, I think, a big deal. I think at the age of 29, he was the assistant professor at ISC, which is really a big deal. I mean, he has completed his PhD, he has completed his postdoc, and then he has joined as assistant professor in ISC, which is literally a big deal to be a professor at assistant professor at ISC at the age of 28 or 29. So basically, he was just teaching that, okay, you can implement the stack and I mean, dynamic array or something like that. Then that was over. Then I got this kind of information on that day, that okay, that is also one possibility. Obviously, at the time of gate, I haven't even thought about it. Then when I was making this question at that time, I just recalled that, okay, I have studied that kind of thing in ISC, so why not I can pause this as a normal question. I think this is pretty much a gate syllabus question. I mean, that can be easily asked in gate, that they can just ask that, okay, what is the total cost. I don't think it is a beyond gate syllabus question, right? So that's why I thought that I can also put this question in the practice set. Okay. So and also I put this question in the quiz. So in the quiz, you will be having this strategy. It is also easy. I think at the sequence will be different, I think, right? So sequence will be different here. It will not be like this. The sequence will not be like this. Sequence will be little different, but it will be easy only. Okay. So the one of the question is that why I have taken n equal to some 2 power. See, in asymptotic sense, n is very large, right? I mean, we are doing the calculations for very large n. Now, what we can think, like, just to make our calculation easy, what we can think, we can say that n to be 2 power something. I mean, whatever it is very large number. Now it must be near to 2 power something. Either it is less than 2 power k or greater than 2 power k. I mean, what we will be doing, if it is, let's suppose, even very large, 10,000, 10, 1 million or whatever, right? We will be doing 2 power k, such that this is very close to 2 power k. I mean, since it is asymptotic sense, it won't matter, because we are anyway talking about the large number. So you cannot say that, okay, my large number is just 1 million. I will say that, okay, your large number is 1 million, but I'm doing my calculation for even little larger number, which is little larger than 1 million. Okay, because we are doing the asymptotic analysis. So you can always represent this n in any power or anything. Okay, I mean, 2 power k, 3 power k, these things won't matter. I think we have done it many times. Or maybe we will be doing it many times. Okay, in data structures, we will be doing it many times. In asymptotic sense, you can represent, I think we have already done it when we were doing the loop time complexity, right? So we were saying that, okay, this loop, let's suppose this loop is going to run 1, 2, then 2 power 2, and then ultimately 2 power k, something like that, right? So we have already done this, and to be approximated as 2 power k in case of loops also. Okay, so this is interesting that the case 2 is also theta of n, and which makes this strategy very efficient. Okay, so I hope that is fine to everyone. Now, this question number 9 is basically a follow-up question of question number 8. Okay, so has anyone solved this question number 9, which was, I think, also very tricky question? Let me know. Okay, so what they're saying, consider array-based implementation. Uh, yeah, and suppose it was initially empty. Now, n push operations are going to happen, will be resized in such a way that running time per push is order of 1 per operation on an average, which means like total push operations will be order of n. For n push, it is taking theta of n. Okay, which means for one push, it is taking order of n. Okay, I mean, that's what they're saying, that on average, that you're taking order of 1 only. Okay, for one push. That can be done using doubling, right? That can be done using doubling the size. How many times the array resize over the n pushes scheme? Okay, so basically they are saying how many times you're resizing. That's easy question. Let me just tell you how. So when you are resizing, let's suppose whenever I mean, here 1, 2, 3, 4. This is, let's suppose, n. Out of these n, they're asking how many times you're resizing. This is the question. Okay, you're resizing whenever the index is 2 power I, right? Let's suppose n is 2 power k. N is 2 power k. So you will be resizing whenever the index is 2 power I, which means you will be resizing at 2 power 1, 2 power 2, 2 power 3, at 2 power k also, right? In between there will be some insertions, but you won't be resizing on them. I mean, you will be resizing only when the insert is 2 power 1, 2 power 2, 2 power 3, 2 power k. I mean, on those indexes you will be resizing. So how many times you're resizing? K times. Okay. And what is the k here? I mean, you are resizing this time. So what is the k here? Can anyone tell me? Yeah, 2 power k is n. That's what I have assumed. So k is log n. So you are resizing log n times. That's the question. So they're asking that how many times you are resizing. So this is B is the answer here. Okay. Actually, I think it should be theta. Okay. I mean, the best possible answer is B, but since B is the answer, that is why C, D, and E are also the answer, right? I mean, if B is the answer, if it is less than or equal to log n, then why not it is less than or equal to n? I mean, if you are putting order, then if B is the answer, then C, D, E are automatically the answer. So that's why let's assume that these are the theta. Okay. I mean, generally these questions are for the best possible answer. I mean, the tightest bound that they look for. But in general, we can argue in the gate also. Okay, so we can definitely argue if order of log n is answer, then why nobody is stopping you to answer this order of n. Okay, and order of n log n or order of n square. So that's why let's just put it theta. Okay, to make sure that B is only B is the correct answer. So how we are solving is that. So what is the question? Let me just repeat it. They are saying that you are inserting first element, the second element, third element, and the nth element. You're inserting n elements. If you're resizing at 2 power k, then how many times you're resizing? Okay. How many times you're resizing? You're resizing at 2 power I. I mean, you're resizing at 2 power 1. You're resizing at 2 power 2. You're resizing at 2 power 3. In between 4 and 8, in between 5, 6, 7, you are not resizing on those elements. You're resizing at 2 power 4. You're resizing at 2 power k. So you're resizing 1, 1, 1. I mean, at these indices, you're resizing. So how many times you're resizing? K times, right? K times resize. Okay. Where k is log n. It was very nice question, but this question is seeming easy just because you have done the previous question. Okay. And the sequence was like this only. Like first I found this question. Then I thought that, okay, if I directly put this question, you will be feeling it very hard. Then I have put another question. I mean, I have put a question which will make this concept very, very familiar. Okay. So using this question, this concept was familiar. And then I have put this question so that you can understand this question. Okay. Let me know if you have understood this. Cool. Okay. I can skip this, right? Because this is easy one. I think you can do it. Suppose you have the stack and then they are asking the stack permutation, right? So give the sequence of push and pop operations such that values are popped in the following order. I think this is also you can do. Okay. This also you can do. Let's do this question, which was one of the hard question. Again, see, these kind of questions are little aptitude kind of question that how to solve. So that's why I put the disclaimer that it is actually hard question. So what they're saying, consider the scenario where we aim to design the stack. Okay, Twinkle is saying that she have found it easy. Were you able to solve that? Oh, awesome, awesome, nice. So they're saying consider the scenario where we aim to design a stack with the following operations. So you want to push pop. I mean, these are the usual operations that we do. You want to do also get minimum, and you want to do all of this in order of one. Okay, I mean all of these operations in order of one. You want to get the minimum also in the order of one. So how you can do it? I mean, you can use the auxiliary one extra stack. Okay, extra stack or the queue, whatever is needed for you. So how you can do it? That's the question. I did it using struct with zero extra stack. Zero extra stack. How you did it, Akash? Akash is saying that he has done with zero extra stack. I can't think of it. Can you tell me? Okay, let's just see. I can directly jump to the solution because it is already written here. So let's just see. This see push. I mean, generally we can implement this push and pop in order one. But we want to do in such a way that we can. I mean, we get the minimum also in order one. So what we will be doing? What we will be doing? Let's suppose this is the. I mean, I will be taking one extra step stack. Okay. Let's suppose this is I'm calling helper stack. Oh, sorry, I have called it a minimum stack, right? In the solution, I called it minimum stack, so I am calling it minimum stack here also. Minimum stack. Okay, this is my original stack. Okay. So what I want to do, I want to keep track of the minimum. Yeah, that is sure. So whenever some number is coming, let's suppose one is coming. Okay, I will push one in the original stack. I will always push in the original stack. That is for sure. I mean, irrespective of the minimum stack, I will always push in the original stack. Then I will check. Let's suppose 5 is coming. Okay. Let me tell you one scenario. Suppose, okay, already these elements are there, and yeah, let's suppose first 4 come and then 2 come. Okay, 4 came and 2 came and then 5. Let's suppose this is the sequence of operation, sequence of push that I want to take. Okay, so 4 to 5. Okay, let me just tell you from the very beginning. So suppose 4 to 5, I want to push 4 to 5. If 4 is coming, then I will definitely push 4. Since is I mean, in the original stack, I will be doing 4 to 5. I mean, there is no 4 to 5, 6, 7, whatever is there. I will be definitely pushing in the original stack. But I want to do step by step because I want to tell you that how the minimum stack I want to work with. Okay. So if 4 is coming, I will pushing in the original stack. That is for sure. But I will also push in the minimum stack. The reason being is that it is the very first element. I mean, that's why I'm pushing. Okay. The only reason. Okay. Now let's just see the interesting case. If 2 is coming, definitely in the original stack. But we need to take care. Should we also push in the minimum stack? See, is 2 useful to me? Do I have already minimum that 2? See, what I want to, what is my final objective? My final objective is to get the minimum number in the order of one time, which means my minimum number should be, I mean, I will be taking help of this minimum stack in such a way that my minimum number should be in the top of this minimum stack, which means if 2 is coming, then just compare this 2 and 4. Which one is minimum? Which one is lesser? 2 is lesser. If 2 is lesser, then 2 is useful to me. Lesser numbers are useful to me. So I will be pushing this 2 here also. Okay. Just listen me carefully. We will be seeing how it is happening. Now 5 is coming. Original stack always 5. I will always push 5. Now 5 is coming. Now, do you need to keep track of this 5? Do you need to push this 5 in the minimum stack? Tell me. See, in the original stack, you will definitely push everything. But do you need to push in the minimum stack? In the minimum stack, I always push the element if it is helpful to me. Is this 5 really doing a good thing to me? I mean, is this a minimum number? I don't think, right? This 5 is in fact greater than this 2. There is no point in keeping the holding this 5, keeping this 5 in the minimum stack. So basically, I will not be pushing in the minimum stack. Let me tell you more example. Maybe after that it will be very much clear. Let me take this sequence. See, let's just take this sequence. 5 is coming. Okay. These are the 2 stacks that I have. Now, this is my original stack. And let's suppose, similarly, this is my helper stack, or I was calling it minimum stack. Okay. Minimum stack. This is my origin. 5 is coming. Initially I can push in both of the cases, right? Okay. Is this okay to everyone? 6 is coming. Now, obviously, in original stack, I anyway have to do it. It's not a question. But tell me, should I be putting the 6 in the minimum stack? Should I be putting 6 in the minimum stack? The answer is no. The reason being is that the reason is very simple. Just understand the reason. Because the 6 is not useful to me. Because I already have the minimum here. See, suppose by chance, okay, by chance I push the 6 here also. Okay. I mean, 6 is done. I push 6 both the places. Now someone is asking me, give me the minimum. Give me the minimum. Okay. At this point in time, okay. Well, I mean, what is the minimum of this original stack? Then can you claim that minimum is in the top of the minimum stack? Basically, I want to keep this as an invariant. Invariant means I want to keep this as a universal truth that minimum stack, top of the minimum stack is my minimum element of this original stack. मतलब original stack में जो भी content है, the minimum of that will be on the top of the minimum stack. Okay. See. Let's suppose I don't have the minimum stack also. Okay. Just understand this. Suppose I don't have this minimum stack. Let's suppose I just maintain a variable instead of a stack minimum. I just maintain a variable minimum. What is the current minimum? 5. ठीक है? 5 आ गया. 6. Let's suppose 6 आया. 6 you keep. Will you update this minimum? I don't think, right? Minimum is 5. Minimum of this is 5. You won't update this minimum. 10 आया. Will you update this minimum? No. 7. Will you update this minimum? No. Minimum of all of this, I can immediately say it is 5, right? I can immediately say it is 5. Now 9 आया. Will you update this minimum? No. Right? 3 आया. Will you update this minimum? Yeah, this time you will update this minimum. You will say it is 3. 8 आया. 8 आया. Let's suppose इतना ही है ना 8 तक. Let's suppose 8 आया. Will you update this minimum? Tell me, will you update this minimum? No. So the final minimum is, you are getting the final minimum is 3. ठीक है, मतलब पहले 5 था, you updated that to 3. So you are not maintaining any stack or anything, you are just maintaining a variable. Okay, let's just understand with the variable. So 3 is your minimum. Someone asked me, what is the minimum of this original stack? Can you return this in order of 1? Can you give me in order of 1? No, I can give, right? I can say it is 3. Minimum of this all of these numbers is just 3. I can definitely say. So basically with just one variable, I can implement this get minimum. Okay, and I can say that get minimum is just this 3. Is this fine to everyone? I will tell you that what is the catch here. I will tell you, don't worry. I will tell you. Okay. Can anyone understand the catch? Can anyone think about the catch? Yes. So now, suppose you start popping. Okay. Yeah. Suppose you start popping. 8 pop kiya. You popped this 8. Now someone suddenly asks me, can you give me the minimum of this original stack? Can you give me the minimum? Answer is yes. Still 3 is the minimum. You can say yes. Very nice. Now 3 is also popped. Now someone asks me, can you give me the minimum of this original stack? I don't think now you can say 3, right? That is one issue. So you can't say 3 is the answer. Okay. So what is the answer? 5 is the answer. Right? And interestingly, this 5 just got crossed off. है ना? This 5 just got crossed off. Which means अगर मैं इस 5 को भी रख लेता तो मेरा काम हो जाता. Which means, let me just explain you with one example. See, what I'm saying here is that, suppose, now let's just work with one minimum, and then you will get to understand that how we need to do all of this, right? Suppose this minimum, I'm just maintaining one variable. Now let's just work with all of these numbers quickly. 5, initially minimum will be 5. It is also 5, right? Then 6, will you update the minimum? No. 10, will you update the minimum? No. 7, will you update the minimum? No. 9, will you update the minimum? No. 3, will you update the minimum? Yes, you will update the minimum, right? So 5 ke baad, okay, this was the 5. And then you are updating the minimum. You are updating the minimum to be 3. I hope that is fine to everyone, right? Now you are updating that to 3. Okay, this is 3. 8, will you update the minimum? Okay, so these are all elements that I got. 8, will you update the minimum? I don't think. Will you update the minimum for 11? I don't think. Will you update the minimum for 6? I don't think. Will you update the minimum for 4? I don't think. Right? Okay. Now, let's just see what is happening. Now, this 1 came. Will you update the minimum now? If this 1 came, I think this time you will update the minimum, right? So you will update this minimum to be 1. Okay. Now 6 has come. Will you update the minimum? No. 9, 13. You will not update the minimum. So basically the minimum you updated in a way the 531. मतलब वो matter नहीं करता how you have updated, but yeah, ultimately minimum is 1. That is fine. Cool. Now someone asked me at this current state of this original stack that what is the minimum? Then what you will say? I think 1 is minimum, right? 1 is minimum. I think 1 is minimum here. I hope you can see all of these numbers. So 1 is minimum. I can tell that okay, 1 is minimum. Okay. Now just listen me carefully. You pop this off. You pop this off. You pop this 13 and 9, and then suddenly someone asks me, can you still give me the minimum? You will say yes. 1 is the minimum. See, 1 is the minimum. I can still give you the okay. Someone will say okay. Now can you still give me the minimum? Yes. If 1 also got popped off, now tell me, can you still give me the minimum? अब minimum 1 नहीं है ना. Now minimum is a variable. Okay, not a stack or something. Minimum is 1. If 1 got popped off, now next minimum is 3, not 1. Can you give me the minimum? No, right? So that is the problem with one variable. So what is the answer? What is the real answer? 3, right? What is the real answer? Real answer is 3. So basically, the real answer is the next minimum. I mean कि मिनिमम को हमने जैसे जैसे अपडेट किया है, अगर वो सारे मेरे स्टैक में होते एक अलग जगह, इफ आई कुड हैव स्टोर्ड दीज नंबर्स 531 आल्सो, ओके, है ना, जब भी 1 पॉप हो रहा है मैं यहां से भी 1 को हटा दूंगा, एंड देन आई विल बी सेइंग 3 3 3 3 3 अंटिल 3 गेट पॉप. ओके, 3 पॉप होगा तो मैं यहां से भी हटा दूंगा. तो ये जो सीक्वेंस है ना, द सीक्वेंस इन विच आई हैव अपडेटेड द मिनिमम, इट इज ऑल्सो इंपॉर्टेंट. Not just the final minimum, but the sequence in which I have updated the minimum, it is also important. Because the moment till the moment 3 is there, 3 is minimum, but suppose the 3 is also popped off. What is the next minimum? What is the minimum of the remaining stack? 9, 7, 10, 6, 5. What is the minimum of the remaining stack? I think 5, right? So this is the number. So basically, how you are changing this variable, if you can also keep a hold on this, if you can also keep a track of this, then you can answer this question. And we will be keeping a track of this in the different stack, which I am calling a minimum stack. Okay. So this 531 also, let me just keep in the one more stack. Let me just explain you from the beginning with the help of the stack. Okay. So basically this minimum stack will be keeping the elements in the you can say from the top to bottom increasing order, or from the bottom to top decreasing order. Okay. मतलब जब भी कोई एलिमेंट आएगा which is lesser than 5, I will keep it. Okay. If it is greater than 5, I will not keep it. The moment I see 3, I will keep it here. Okay. If it is greater than 3, now I will not keep it. Okay. If it is greater than 3, I will not keep it. Till 4. Okay. Till 4, I will not keep it. The moment it is lesser than 3, I will keep it. Okay. Which is 1. Now, if it is greater than 1, I will not keep it. So in the minimum stack, I will be keeping 1, 3, 5. Yes, minimum is on the top. If minimum is get popped off in from this stack, I will pop up from this minimum stack also. Now the next minimum is 3. Okay. And the next minimum is 5, like that. So basically what I'm doing here is that I'm keeping the minimum on the top. Okay. And in the decreasing order, you can understand from the bottom to top. So basically every time I see some number, if it is useful, I will keep it. Okay. So 5, 5, that is fine. Now 6 is coming. 6, both the places. Oh, sorry. At this place, obviously it will be there. Will you keep this 6 here also in the minimum stack? I don't think, right? Okay. We will be keeping the minimum only on the top. Okay. In the minimum stack, so that I can get in the order of 1. 6, 10. You keep 10 here. You keep 7 here. I mean, 7 is greater than this. You won't keep it. You keep 9 here. You keep 3. Now 3 has come. You keep 3 here also and here also. This is the catch. You keep this 3. Don't delete this 5. Don't delete. Earlier, what we were doing? Earlier, we were deleting this 5 in the sense that we were just maintaining one variable. You maintain 2 variables now. Okay. You maintain a stack. I mean, you have to maintain the multiple variables, which means you have to maintain the multiple numbers. And that is why you can take the stack. Okay. Now, this 8 has come. Push 8. 11. Push 11. 6 has come. Push 6. 4 has come. Push 4. Okay. 4 has come. Push 4. Now 1 has come. You push 1, but you keep this 1 here also. Because 1 is lesser than 3. Whenever it is lesser than this 3, you keep it here. 1 is okay. 6, 9, and 13. Now 6, 9, and 13, you can definitely push in the original stack. You don't need to push in the minimum stack. Okay. So this is 6. Now, whenever you start popping, okay, now this is the push. Now, if you want to pop, you can pop this 13. If this 13 is also on the top, if these two elements are matching, which means you can't just delete from here. Okay. I mean, if this is the same element here, you can't just delete it from only once. You have to delete it from both the places, right? If 13 is also here, you delete it here, but since it is not here, 9 you pop, 6 you pop. If you want to pop 1, then this is interesting. If that is also same as the top of the stack, you have to delete from both of the stack. So you have to delete from both of the stack. Now, if someone asks you what is the minimum of the remaining stack, can you tell me minimum in order of 1? What is the minimum? Minimum is 3. Okay. The top of the stack. Yes, top of the stack. So minimum is 3. No, this will work even if you have duplicates. That's not an issue. Okay. Even if you have the multiple ones, you push the multiple ones here. I mean, you push even if it is equal. Okay. If it is, let's suppose you are having multiple ones here. You push this one here, and now you push this multiple ones here also. I mean, that's not an issue. Okay. Yeah. It's not like that you're I mean, if I got your confusion that you might be pushing here twice and here just once, right? And at the pop you are popping this, and then it might be some confusion or like that. If it is multiple minimum, so basically what is the criteria to push in this stack? If the top of the stack is lesser than, or I mean the top of the stack, you can say the greater than. Okay. I mean, if this 3 is greater than or equal to, okay, the number that is coming, that is you can say, you can say in that sense, if the number that is coming which is lesser than or equal to the top of the stack, even the top of the stack is equal to the number that is incoming, then also you can push it. Okay. So that's the only change. Okay. So I hope you understood this. Sorry. So basically, suppose the elements are pushed like this. Here in the minimum stack, we are storing only 5, 3, and 1. And in the main stack, we are storing everything. Now let's start popping. If you pop, you can understand this question. Right? It is very rare to think algorithm by yourself, but just for the sake of knowing, sake of practice, I have put it in the practice set. I mean, that is the purpose of the practice set, right? Okay. So I hope you understood. Now let's just move to the next question. What is the order in which I think you can do this, right? So basically, you might have noticed that this stack and queue questions are either too easy or too hard. I mean, like actually, I was not able to manage the balance. I mean, in the sense that I have put the balance parenthesis questions, that is fine, but I was not able to maintain the balance in the questions. Like mediocre questions, I was not able to find. So either these were the too easy or too hard questions that I was able to find. Yeah, obviously there might be mediocre questions also. Okay, let's see this question number 15. So they are saying that which implementation is the best implementation, or which implementation not best. They are saying that which implementation will work, right? Which of the following choices should be the valid initial choices? So basically, we have seen two choices, this choice and this choice we have seen. And now, like, eventually you can initialize with everything. Like this, the purpose of this question is to make you understand that it is not the case that these are the only two choices. Okay. See, you can do the third one also. I mean, doesn't matter. You just have to, it is saying the front is -1. Okay. F is -1. And back is this capacity. This is the rear, right? Rear or back. So basically, they are saying that that you can initialize. These are just initial values, right? These are just initial values. You can initialize with anything. The moment you do first push, okay. The moment you do first push, you may be just resetting this R to be 0, or maybe, I mean, you can do your own implementation, right? You can do your own implementation. that is not an issue. So basically, you can pretty much do anything. You just need to modify your own functions. Now to push, maybe you can immediately set this R to 0 on the first push. Who is stopping you? Right? So basically, the idea of this question is to make you understand that it is not the case that we can only do with these two cases. You can do anything, whatever is coming to your mind. Is this clear to everyone that why we can do anything? Because we just have to adjust our functions, push and pop functions that we are going to write. Oh, Rishesh is saying that it is his first live class. So yeah, like we are. I hope you are having fun. So I can see that you are answering like questions, even to the complex questions you are answering. So yeah, we are actually about to end this class because I think time is almost up. Okay, so we will be seeing remaining question in the next class. So the idea of this particular question was to make sure that you understand one thing, which is that you don't need to buy hard that only two choices are there. Okay. Devans is also saying it is also his first class. Okay. Welcome, Rishesh and Devans. Cool. So Dinga is saying it is also her first class. Good. So basically, I know that most of you might have picked this fifth option, which is saying the array-based Q lectures was so confusing that I have no idea how to answer this question. Even in the solution, the solution was like that. They were saying that in the solution, they were saying that you can pretty much argue that fifth option is correct one. Okay, you can pretty much argue on that. I think on this particular link, they were saying like that. Okay, Satyam is also saying it's his first class. It is also my first class. Yeah, that is nice argument, I think. Okay. So frankly, as long as you're consistent across all the Q functions, any pair of initial values of the index will work. I mean, you need to just modify your push and pop functions. That is all. So basically, generally in the gate or in any place, they don't generally care about the internal details of the stack and queue, because even if you do the competitive coding, then also you will be directly getting stack and queue if you're doing in C++, Java, or in any other language apart from C. I think in C it is not directly available, but in C++ there is a standard template library. In Java, you have the collections. So you will be getting stack and queue ready-made. So nobody generally cares about the internal details of the stack and queue generally, right? I mean the internal details, but it is better that you know. Okay. So I hope that is fine. So let's do these remaining questions in the next class. Okay. So thank you everyone. Thanks so much for joining. So we will be doing the remaining questions, which are also good. I think this question, let me just tell you one question which was quite good. Yeah, this question was very nice. Were you able to solve that question? So this was the question, right? What is the answer that you are getting for the case B? Anyone? You have solved this question? Answer is, I think, n log n. Okay, this question is okay, very tricky kind of question, I can say. So basically they are saying that if you want to push something, that you can only push in the first stack and then you have to move based on that. Okay, yeah, we are anyway leaving, so I think we will be continuing. Yeah, that question also very nice. This question also nice, the probability based question, right? Yeah, this was one question that I put in last year quiz, I think. So from there I taken this question. Okay. And as this question is saying, it was an easy question. Okay. So thank you everyone. Take care and bye bye. Thank you. Thanks so much.